First of all, thank you everybody for coming. Your time is once it's spent, it's gone forever, so it's priceless and thank you so much. So yeah, we're here for our FPGA Projects Meetup on the 13th of May. And what we do, we talk about what we've done and what we have planned for the future, if we have any roadblocks, and if we need any resources from ORI, or if there's anything we can coordinate with others. All right, so Thomas wrote me and he says, gosh, can't be there today because I'm at Beyond Earth workshop from 12th to 15th of May. And this is just a little high level overview about where Thomas is at for the next couple of days. And I'm a little bit jealous because it sounds amazing. So this is a lunar and space radio mission from Beyond Earth. And I'll put the link in the notes for the recording. Sounds amazing. And when he comes back, he will be able to share with us all sorts of things about what he learns and what he's going to report. So he's going to bring all of the work from Dwingelo and Stockert and all of the other folks they work with, like DSES, to the workshop. So sounds cool. So that's where Thomas is at. But he says hi to everybody. And then my report, I'll just give you the bullet points for the last week or so. A major update of the Earth-Venus-Earth link analysis was published. This included some big updates for sections of it, and there's still work to be done. I actually filed an issue, reminded through my comments about a part of the link budget analysis that actually could lead to some errors, because in the system temperature section of it, there's things that really need to be in the site-specific data classes that do not need to be in the worksheet. There's a meeting later today with the Deep Space Exploration Society principals, the president and one of their active engineers about EVE 2026. This will be the next inferior conjunction. They wanted to talk about something. I'm not sure exactly what. They mentioned link budgets and possibly dish measurement. So we put together a proposal for how you would measure a large dish, and it's on our website as an article, and I'll know more later today. So things moving forward there. Our annual tax form submission, May 15th, is the typical deadline for nonprofits to file their tax forms. For individuals, it would be April 15th, and for people like us that are 501c3s, it's May 15th. So coming right up. I've got everything that I need, and we'll be sending it out for review. Should be okay. We have relatively simple 990s. We have to file the full ones, the full 990. There are simpler 990s all the way down to just a little postcard. We have to fill out the full 990s because of the amount of funding that we've received and the amount of money that we have. So we owe some transparency there, and we take full advantage of that. We'll be filling out all of the different parts to talk about our different projects and the challenges and successes that we've had. 4 out of 4 submitted articles for QEX magazine from ARL have been accepted, and moving forward with that. I don't have publication dates yet, but I've been told that all of them will come out over the next year. This is every bi-monthly, so there's 6 issues per year. So over the next years, that's pretty good. That's good. We participate in the IEEE standards group, the P1954. This is a drone radio protocol. That meeting was supposed to happen on the 7th of May. It's been postponed to June. They kind of came out with the link for the Zoom call a little bit too late, and the owner of the white paper asked for a delay, and that was granted right off the bat. So if you missed out, you want to be involved in that call. This is essentially relating to our Neptune OFDM physical layer protocol drone project. So if you're interested in that, since we're on the group, you can attend. So let me know. there's an article about delay Doppler channel communications from Pete. It's progressing pretty rapidly. There's been lots of back and forth and some review, and then things are coming along, and he'll talk about that coming right up. And we published a regulatory proposal article concerning the legality of amateur LTE communications and all the interesting things related to regulations about that. That's gotten picked up by a couple of different outfits. So we've seen it get picked up and linked to a couple of different places. That's good. We're planned quite a bit about Opulent Voice's state machine. This is the part of the Opulent Voice protocol that takes all the different incoming communications types, like a keyboard chat, a file that you want to send, or voice, live, real-time voice, or voice memo, and also the authentication authorization messages, and figures out how do you pack all of that into the protocol. How do you frame it all up? But we don't have any lab progress to report yet. So there's lots of thinking that has been done there. Because a lot of this other work, I cannot report any lab progress yet. We're talking about having a board meeting at Omega Mart in Las Vegas at DEF CON, possibly on the Sunday of DEF CON. That is actually a day of the conference, but we're talking about either Sunday or the following Monday. Following Monday is difficult because most people, if they don't fly back on Sunday, they're definitely flying back on Monday. But this is a really neat venue and a neat opportunity to have fun and get together. So we'll be putting out a proposal about that. And we got a really nice update from Ribbit, our Ribbit project in the user interface, but we're not seeing it yet in the web app. So I have a question out to the team to kind of like, okay, so you've announced this nice update that fixes a longstanding confusion over the user interface and how to get the messages to work. But it didn't seem to take in the web app. So that's on me to turn that back around. Okay, so that's my report. And then we'll turn the floor over to Aaron. I know you have time constraints, so if there's anything that you'd like to talk about, you have the floor.
Thank you, Michelle. Sorry I haven't been around lately, but I just wanted to report that I'm still around and I'm still thinking about this project. I've been busy with work and other activities. The last thing I was working on was related to the DVB-S to decoding and encoding. I had, like I reported before, a solid decoder now, and my next focus will be implementing Everest Pluto SDR implementation of the encoder, the ORI's implementation of the encoder on the Pluto SDR and getting that decoded, and then moving on to OpenCPI, implementing that within OpenCPI, which will then open the door of other platforms besides the Pluto to be able to use the encoder. So that's what I've been working on. Thank you.
No, thank you. That's a big deal, and I'll include links to Everest's work. And yeah, good. If there's anything we can do, let us know. This is great
Will
stuff.
do.
Thank you so much. Okay, and we have Pete's work, and he has a really neat diagram here. It's a good visual, and the floor is yours, Pete.
Oh, thanks. Yeah, I'd had a chat with especially Paul and Brian, and they gave me a few hints on how to tune up the problem definition. So that's what this is. If we start in box one, you can see basically the laydown. It's the normal system components. It does look a little bit like a moon bounce channel because we have path loss and the reflections off the different craters of the moon, and then path loss coming back down. But the important part is I've defined a metric. And in box two, it starts with the energy per transmitted symbol. So you can see that's just the signal out of the transmit after the transmit antenna gain, X of T. And of course, we convert that to power by magnitude squared. And then since energy is power times time, we integrate it over time. So that's the energy per transmitted symbol. Then in box three, we have the energy per received symbol, which is the same thing, just integrating the power over time. But in this case, it's at the antenna, the receiver antenna output. So these are different values, of course, because they've traveled and had a lot of path loss and whatever the channel did to it. So then In box 4, the idea is that a lot of folks have looked at efficient ways in modulation and coding to use energy that actually arrives at the receiver. But a different and important problem is for constrained transmit energy per symbol, how much of it actually arrives at the receiver. And so I defined an efficiency metric as the ratio in dB between the energy per received symbol and the energy per transmitted symbol. So then in box 5, if we take a look at that for a single path, there's just a path coefficient and a delay. So the received signal y of t it's just scaled by the path losses, the gain of the receive antenna, the path coefficient, and it's delayed in time. Simple one path. So then in box 6, we'll look at the energy efficiency metric for that. And it turns out that if we take that ratio of the energy per symbol at the receiver versus what was transmitted, it just becomes a function of the path loss, the reflection, the reflection coefficient, and the gain of the receive antenna. There's nothing in there about the shape of x of t. So that shows that normally with a single path, who cares? Don't bother to design waveforms. But then in box 7, if we advance to the multipath, what happens is we have to recompute energy per symbol E sub s at the receiver. And now that still has path loss in it, and it still has the gain of the receive antenna, of course. But it's the convolution of the waveform we send with the channel response, and there's more than one path. So as a result, in the bottom right, it shows that multipath efficiency with more than one path now depends on the shape of x of t. So this just lays down a metric to show how the problem fits a realistic model of the system, and then shows that, of course, it doesn't show how, but it shows that different x of t's will have different efficiencies. And that's the reason why I've been playing around with designing different waveforms for x of t. So I think that's all I had in the chart, but I'll pass it back and see if there's a feedback or clarification.
Cool. Okay. Any questions? Questions or comments? Pete, do you want to talk a little bit about your proposed articles?
Sure. Yeah. So I'm sort of thinking that, given the way all this evolved in the comments, maybe I'd break it into a series of short articles. So there's a huge body of work, and it's like 12 pages long or so at this point. But it might make sense to break it down to this one first of all, just to say, here's an interesting different metric. Everyone talks about modulation and coding in terms of ES on N0, but they don't necessarily look at how much energy was transmitted versus how much arrived. So the metric is an interesting part. And then, of course, applying the metric could be one or two follow-on papers, because then there are good ways to design these waveforms, including for delayed Doppler channels. And that borrows heavily from the OTFS modulations, but it uses them in a little different way, because OTFS right now is sending waveforms that the paths are combined separately in the VMod, not by the channel. And so there's important performance differences there. And it's a way that could buy us dBs of performance if we know the channel. And there's interesting things about knowing the channel, because we normally think about estimating a channel and it has a coherence time, but when you do it in the delayed Doppler domain, it ends up being, in many cases, much longer than what we conventionally think of as a channel being, well behaved. So that would be another piece, would be to look into, if you know the channel or can predict it better in the future, of course, this all works better. If you can't, it doesn't really work that great at all. It works kind of like normal things we do. So looking into how well we can predict things using delayed Doppler, since it really is different. It's a different way to look at channels, and some channels that we might have thought before were only stationary for a half second or a second might actually be stationary for longer than that. So I think those things together are why I'm interested in it. It still may be a little bit hopeful that we can estimate and predict the channels, but there's also reasons why, with the new delayed Doppler OTFS view of the world, we can probably do it better. There are better ways now to do things. And the magic is to understand it well enough to get back to over-the-air testing that's smart, and then prove whether or not it works.
Yeah, I think that's very well said. I think the advantage that we have is that we have an opportunity to design a protocol or design a communications, a package of SIGMF described transmitted symbols that matches up really well with a channel that we can uh, know a lot about, the Earth, Venus, Earth, or Earth, Moon, Earth. And in a lot of cases, like the OFDM and the OTFS channels are dealing with terrestrial cases, and these are much more messy than what we have for amateur targets, EME and EVE.
Yeah, one of the interesting things, of course, is that the moon's a rigid body and it's rotating very slowly. So there's reasons why we might be able to better predict that channel accurately into the future than like an L-band wireless channel on 5G or something driving down the street in Manhattan.
Exactly. Well said. Yeah, that's so we can draw out the advantages and the techniques here and make a very clear case that isn't just in math, but we can also carry it out in the physical world and then report back. And anything that leads to the achievement of what we would call communications, better communications with EME and actual communications with EVE, beyond just bouncing a carrier wave off of the body, would be a big step forward. So it would also.
And the only reason to go through the math torture is to design better experiments so that, should we get a chance again to run something on Dwinolo or another EME site, understanding it really well will help better design the experiment.
Yes. Yeah. And I think Dwinolo and Stockert and DSES and others are very enthusiastic about giving this a shot. So the next best opportunity for Venus will be in October of 2026. And if we keep it up, I think we can have some really good options for folks to try. So yeah, very exciting thing, and plenty of educational opportunity here. These protocols, especially OTFS. There's not a whole lot out there that's accessible and well explained. There are some OTFS explanations, but they're targeted towards some relatively narrow use cases that tend to be terrestrial. So I think we have an opportunity here to kind of contribute to good technical education and sort of professional development and giving folks a sort of a clear view and some models and some actual results in the end. So
yeah, I think we could probably write, or I could write some stuff that would be a lot clearer on OTFS than what's out there. Because when I finally drilled down to the Zach transform, it's actually shockingly easy. So I think that'd be another area. And of course, I can be steered and convinced easily that certain problems or things are worth looking at or writing about. So anyone just suggest whatever.
Yeah, please proceed. I think your instincts are right on the money. There's a lot of things in digital signal processing in general that I think Matthew probably knows what I'm getting at. There's things that are not documented well in the public. That the resources out there, even Wikipedia, have significant errors, and we have a good opportunity here to improve science and technology, communication and education. So yeah, please dive in wherever you see you can improve it, and you get our full support. Cool.
Thanks very much.
Yeah, no, thank you. This is fabulous. All right. Let's see. Say, Paul, any updates about the lab work? Plans for the future?
Little ones. As people will recall, I now have two copies of the computer system for the remote lab, one in the remote lab, what I'll call the test system here, which is currently here in my personal lab off screen to my left. One of the purposes was to prototype software changes, including the Unraid version updates. I now have the live system running on 7.0.1 of Unraid, and the test system's running on 7.1.0 of Unraid, and neither of those is current anymore because the Unraid guys have made changes while I was messing with it. So I've got a zero point zero zero 0.001 increment on to install on the test system, and then I'll probably bring the live system up to that level too. Um, and I've made some preliminary tests with configuration to try to improve performance based on the usage of uh, SSDs, but I don't have anything real to really report on that. That's future work still, and I guess it's about all I have to say about the remote lab right now. Oh, the other um, major improvement here is that I got the test system off my bench top and down onto the floor. So I now have my bench top back and it's cluttered up with something else already.
Very good. That's the way it goes. Yeah, it's one of the I think one of the effects of using something that's under active development is that we have to keep up with the versions, and I guess that's good news, but also a little bit extra challenge. So thank you very much for helping us improve remote labs, and very glad to hear about the forward progress. Anything that you need?
Not at this time.
Okay, awesome. All right, so I'll turn the floor over to Matthew uh, to give us updates and reports and anything that he needs.
All right, thank you. So I've been focusing back on the MSK modem this last week, cleaning the code up, and then just doing a deep dive into the simulation to find out where I've gone wrong in the demodulator. I'm thinking I'm getting close. I'm hoping I'm getting close. And I still am tweaking the differential encoder, the Massey versus the Scoons encoder. So I think that was still kind of like half baked, just probably part of the issue. But I think I've settled on the encoder implementation more from the Scoons and trying to now get the demodulator to be happy. It was doing some weird things, and it was odd after when we first changed the encoder, the demodulator started acting funny. And it wasn't clear to me why the encoder shouldn't have had any effect on the demodulator locking. It would have an effect potential on the data detection, but I was seeing other issues. I think those are cleaned up, so now I'm just trying to get the data detection working correctly. So part of then this is a good effort in that the I'm just going through and trying to make sure that the data alignment as it's going through pipeline delays is good, and that there are certain calculations aren't being done on the wrong pipeline edge, if you will, or the wrong spot in the pipeline, which messed things up. So I'm trying to just go through that in detail and clean up the code in general. And hopefully once that's done, we'll have a more robust implementation for the demodulator. And then, so that's the primary thing right now is get the demodulator stable again. And then once we have that, then get back on to working through the list on the Trello board. I think that's it for this.
Oh, that's a lot. Thank you. Yeah, I think I owe you, what do I owe? Do I owe you anything? Are you waiting for me for anything? I think I owe you an update on the separate sort of relatively independent effort for the quality of service. I mentioned that very briefly.
Yeah, I don't think there's anything I need there, but Paul and I did have a long discussion on, hardware software partitioning. We probably need to come to an agreement on that. Because if we there'll be some more stuff that goes into the hardware potentially. If we, my kind of argument is we should have a hardware level framer. It doesn't have to be, it could be very simple, but if there's no data to send, the hardware should keep sending something so that the receiver stays locked. Right. And so I my feelings is that's a hardware level mechanism, and then we just take very simple data from the software and map it into that frame. But it's not. There's nothing set in stone, of course. So I think we just at some point need to meet and kind of come to an agreement as what that hardware software positioning looks like.
Yeah. I put out some questions and started working on trying to figure out what we could accomplish in software. And the first thing that I wanted to kind of like figure out was, where do you do the Opus encoding? And we looked and we found no existing Opus encoder in hardware in VHDL, at least not open source. We did find a couple of projects that kind of like said, hey, we're going to do it, but they're empty. So you can see that there was there's multiple people that have gone like, oh, this is a great idea, but not really every, uh, not quite followed through. Okay.
And that was for hardware implementation?
Yes, for hardware implementation, because I'm with you. I think I've admitted to this bias several times that like the most you can do in hardware, the best outcome you'll get. Like I'm very biased to do as much as possible in hardware. Um, in our particular case, I think there's lots of software implementations of the Opus encoding, so to encode the voice into an Opus frame and then deliver that to a hardware port or queue, and that the queuing up the preference or the priority, the state machine. I've My bias is that that should be part of the hardware solution, that could be part of the hardware solution that we figure out, and okay, I can be moved either direction, but as of today, what we're trying to do is find a good Opus support for the processor side to see if we could possibly fit it in a Zinc 7010. Jury is still out on that because of your research, that you dug into this, and it's possible maybe to do the Opus encoding at voice rates on board the existing processor. So we'll give it a shot. I think that the Lib Opus library, the Opus library, Lib Opus, it looks like it's already a good chance it's already in the Linux build that we're using, the build root that Evereast pulled together for MSK Pluto. I haven't yet tested that, never got over to the lab over the last couple of days. Might not get back to the lab over the next week because my daughter's graduating from college. We're going to have a road trip about that. So I'll try to get it in. But that's one of the next tasks. So it's really on the kind of the hot list to kind of like go ahead and confirm if the library is already there, that we can just write some code and figure out like to try it. If we can do that, the rest of the queues for the incoming data, like for keyboard chat, for file transfer, for authentication authorization, I think that those are simpler cases of just putting them into queues, and then on the hardware side that you handle it all in a state machine. And in Simulink, the state machine looks kind of scary, but it isn't. It's just deciding which one of these gets priority and waiting and handling timeouts. So, if we don't get any data for a long amount of time, we keep the link up for a while, times out, we drop it. When we get new data, then we start it up again. Or we can extend this timeout for quite a ways. Or we can just do the DVB-S2 approach and have dummy frames forever. So there's lots of leeway here. We do need to start making some decisions, but I think we've got a good design for the prioritization of the different types of data. We've got a good working model in Simulink. I'm okay. My bias is to put that in hardware, but to put the data preparation, like the Opus encoder, in software. So that's what I'll explore over the next week or two. It's probably going to be 2 weeks for me because of the graduation stuff, which is just a happy thing, a happy delay, not a bad one. But I may be kind of scarce over the next week or so. Hopefully come back with some good drama stories and great photos. So that's kind of my thoughts on it. I think that we got a good split between the hardware and software. I know that we're kind of close though on the hardware resources on the 7010.
That's kind of the issue. But I think that if we just do a simple framing in hardware, I mean, I don't know, it doesn't even necessarily have to have a state machine. It could be even simpler than that. You just three priority queues, and it pulls from the highest priority. And if there's no data there, it goes to the next highest priority. And if there's no data in any three of them, we just send, a dummy frame of PRBS
Yeah,
or something.
that
So I
sounds
mean, it could be
sounds
really,
like
really simple.
okay. That sounds like what we're achieving with the state machine. Does the state machine, like in hardware, would that incur more than priority queues or?
No, I mean, state machines don't take up much space, but I mean, it's kind of the same thing, and it kind of depends on the underlying frame structure. Um, and if you need to put pointers into the frame structure, uh, like you could have a frame structure that always sent a little bit of overhead, but then mostly data, and then you'd have to allocate that somehow, or you might have pointers like the cobs. But yeah, I mean, but again, it could just be really simple. You can even do something like if you wanted to do some encoding to make the frame sync easier at the receiver, you could do like an Ethernet 10 gig type encoding where you do a 6466 frame, and then the two header bits used for synchronization, frame synchronization, and then the if it's a certain bit value, it means the next byte is a control word that tells the receiver what's in the frame. If it's say it was an Ethernet packet, it would say start a frame, or it would say end a frame, and how many valid bytes are left in that in that frame. So I mean, there's lots of options of how you can do the framing. The 6466 one actually works really, really well, and it's derived from the Ethernet standard. So I mean, we just, like I said, there's I'm sorry, and then with the 6466, there's not really. I mean, there's a state machine kind of at the receiver, where you have to lock to the frame, incoming frames, and that can be a state machine to have like a trial lock, and then a trial and lock, and in a lock state and a startup state. So, but again, that's it's like a 4 or 5 state machine. It doesn't take hardly any resources.
That's good news. That's
But at the transmitter, you might there could be reasons for a state machine, but in my experience, it's not really necessary, in that the hardware just picks the priority queue to pull from, the highest priority data queue that's there, and pulls from that effectively until it's empty, and then pulls from the next queue.
right. Yeah, that's the behavior that we're after, is to pull from different queues as long as there's information there. Keep the link up as long as practical, and then restart everything if there's more data.
Yeah.
So
And then if there's nothing to send, then like I said, you can send a PRBS frame or an idle frame of some sort.
right.
Assuming that you want, once the PTT is asserted, that you want to keep transmitting until the PTT is deasserted, right? And that helps the receiver to stay in lock.
Exactly.
What does it say? But you might, like, if you're in the middle of a frame and then the high priority queue starts getting some data in it, depending on how long the frames are, you might want to switch over to that high priority data. So that's kind of the wrinkle in this. If the voice data, which is was the most critical, it would be, you might want it to preempt data transmission already in progress. So that would be kind of the wrinkle in this, that we would have to be able to mark that changeover within a frame, so that the receiver decodes it properly and puts the received data into the right receive queue.
Right. Yeah, this is all good, and needs a lot of, it needs an actual I think a low level review. We've done a high level review of the idea, and have a good simulation. But yeah, I think it's probably time to dig in and really scrutineer it. So
Yeah, I mean, I
next couple of
should
weeks.
make a proposal for what to do at the hardware level, and then we can, kind of synthesize it or
Right.
come to meld the various approaches to find something that meets the need, that we all kind of, the collaborative process, I think, is really beneficial, because then you have multiple points of view, and everybody has to kind of think about things from a little different perspective. And, we kind of end up, I think, with the best approach, with that kind of collaborative, even antagonistic's not the right word, but I mean, when you have to come in and defend a proposal that you've made, that's a good thing, because it means other people are trying to poke holes in it, if you will. And then you can either defend it, or you find that you need to rethink it a little bit. And that's, a good part of the engineering process, in my mind, is to work through those issues, and you end up with something better in the end.
Yeah, completely agree. We tried to do a good comment and critique, design review sort of process here. And yeah, I think we're moving into the point where we've worked through the high level ideas here, and we know what we're after. But the things you're bringing up are, that's the next step to, in other words, scrutinize and start talking about, moving it from math land and from Simulink to, okay, so now what would it take to get this synthesized in hardware? And the real compelling question is the division between the software and the hardware side, which, for deployment on 7010 or 7020 or 7045 or whatever is in our future, then that's a critical question to balance out the hardware and software side.
Yeah. And one of the reasons my argument for the partitioning is Pluto is a really nice development platform. It works really well. But if we want this whole project to be portable to other platforms, you may want to use an inexpensive FPGA that wouldn't have the processors on the FPGA. So you might have the processor on the board somewhere else. And so you want to simplify the data that's being transferred between the processor and the hardware. And so you don't have as tight a coupling as we might have in the Zynq products. But thinking from this higher level of what we might want to be able to port this to, say, with a Raspberry Pi, with a simple, one of these inexpensive Chinese FPGAs, would be a very cost-effective platform. But that hardware software partitioning then should be something that accommodates these various platforms that aren't the Zynq.
Right.
That's kind of my argument, where I'm coming from in some of this as well.
Yeah, that makes a big difference, because getting on and off chip, that transition is super critical, and it varies hugely from something that's integrated like the Zynq to something where you have to go to a separate processor. So
Right.
that becomes your bottleneck by quite a bit. So yeah, I'm looking forward to all of this. And thank you so much for all the work and the leadership here. It's deeply appreciated, and should have a lot of good things happening over the next couple of weeks.